Welcome to the deep dive. Ever wondered how, the brains behind big industrial machines get managed? We're talking PLCs, programmable logic controllers. Today we're digging into a YouTube video from Fabien Cheval. It shows the process for backing up and restoring PLC logic on Okuma machines, specifically the OSP P100, and maybe the P2 as well.
Right. So our goal today is really to understand how technicians or operators keep these complex systems humming along by managing these backups.
Exactly. Think of it as like the essential knowledge for maintaining the machine's core programming. The video gives us a really good visual walkthrough.
It does. It shows the actual software interface, which is super helpful.
Okay, so first things first, how do you even get into the PLC software? The video mentions a program called D300win.
Yeah, that seems to be the standard tool for these Okuma controls, but what's kind of interesting is how they access it in the demo.
How so?
Well, it looks like they're not on the machine itself. They've actually copied the machine's DN structure, you can think of that like its hard drive contents onto another computer. Oh, okay.
And then they run this mwt.exe file from inside that copied folder structure.
Ah, so it's like working offline to avoid messing with the live machine.
That's exactly the idea, yeah.
Yeah.
It creates a safe space to handle backups or prepare restorations. And within that copied structure, there's a specific projects folder.
Gotcha. And that's where the actual PLC program files live.
Precisely.
Yeah.
All the logic is tucked away in there. This offline method is, well, it's just much safer.
Makes sense. So let's talk about the main event. Restoring a backup. How does that work?
So the video shows these backup files have a ZWT extension. It's essentially like a compressed archive of the PLC project.
Like a zip file.
Basically, yeah.
Yeah.
And when you go to unzip it or restore it, the video points out a common prompt that you'll probably see.
Right, I saw that. And the advice was?
Just say yes to all.
It's usually asking about overwriting files, and if you're restoring, you generally want the backup version to completely take over.
Okay, simple enough. Why would someone be doing this restore in the first place, though?
Good question. The video actually ties it back to a change they made in a previous demonstration. They modified something inside what's called a POU, a Program Organization Unit.
A POU, so like a specific module or section of the code.
Exactly. This one was named CHK1Z42, and they specifically tweaked something in block 21.
And what was the tweak?
They'd added a parallel connection to a physical output signal. Imagine adding another path for electricity to flow to turn something on.
Okay.
So by restoring the specific ZWT backup file, they're bringing that modified logic back into the project they're working on. It shows you can reapply changes or even roll back if needed.
Right. So you restore, you check the logic, make sure that parallel connection is actually there, like in the video.
They verify it.
And then you need to save this restored version, presumably.
Yeah, the video briefly shows that. When you close the project in D300win, it just prompts you to save.
And you save it back into that copied Dion structure folder.
Yep. And you'll notice the file date changes, which is a quick visual cue that you're now working with the newly restored version. It's not the original anymore.
Makes sense. The video then kind of hints at a few next steps, right?
Yeah.
After restoring or modifying.
It does. It mentions compiling the program. That's sort of like checking the code for errors before you'd ever load it onto the actual machine.
Okay, like proofreading.
Kind of, yeah.
Yeah.
And building the cross-reference, that's super useful for seeing how different parts of the program interact, inputs, outputs, memory bit,
For troubleshooting and just understanding the flow.
Exactly. And there was one other term, revealed de proyecto. Sounds a bit more involved.
Yeah, the video suggests it's a more comprehensive way to review the whole project compared to just compiling or what they call a make. Maybe it digs deeper into dependencies or something.
Could be. The main point is there are steps after just restoring the files.
So wrapping this up, the big takeaway seems to be that managing these PLC backups, being able to save them and restore them correctly, is just fundamental for machine maintenance and updates on these Okuma systems.
Absolutely critical. It's your safety net. If something goes wrong or if you need to implement a tested change, this process is how you do it reliably.
And it really drives home that you need to, understand what's in those backups. You can't just restore blindly, right? You need to know what version you're putting back.
That's a huge point. Documentation, version control, it all plays into using these backups effectively. Restoring the wrong backup could cause big problems.
Definitely. So it leaves you thinking, beyond just the software steps shown here, what other maybe procedural knowledge or diagnostic skills are really essential for people managing these complex automated machines day to day?
That's the million-dollar question, isn't it? It's more than just clicking buttons.
Food for thought. Well, thanks for diving into that with me.
My pleasure.